Yo guys, welcome back to another video. So here we'll be looking to attempt to solve this trigonometric equation using this interval. Now the first thing I want you guys to notice is firstly this expression. So this is pretty much a typical one. Any equation that involves sine and cos, the whole purpose is to rearrange them back to either sine or cos. And the smart thing to do is to just consider some identities. First, I would have a look at this one. Why? Because we should know that cos squared is actually part of the typical sine squared x plus cos squared x equals 1 identity. Notice that we can rearrange this one to make cos x squared the subject. So hence subtracting sine squared x, we should have this. And there we go guys. Pretty much putting this back in, we have an equation in terms of sine. So let's have a shot at this. Okay, so I'm going to write from here. Replacing cos squared x, we should have 1 minus sine squared x here, plus 7 sine x minus 2 equals 0. Of course, expanding this and simplifying, so I'm just going to expand this quickly. We should get all of this. So if you guys already know this and doing it, I would suggest, try and attempting this yourself. So now here we got collecting terms. We got 4 take away 2 is 2. And putting everything on the other side to make this term positive, we should have 4 sine squared x minus 7 sine x minus 2. Again, I just threw everything onto the right hand side. Now here we are, a typical quadratic equation. What do we do? Well, the best thing to do now is to simply factorize. So let's have a try. So I would say firstly, let sine x equal y so we can see it clearly. So we're going to have, of course, 4y squared minus 7y minus 2 equals 0. So factorizing this, what do we have? First we have 4y here, we have a y there, send this to 0. We just need to think. Of course we have 2, so 2 is a prime number, so we can only use 2 times 1 to get 2. Because we have a 4 here, we can say 4 times 2 is 8, subtracting 1 will give us 7. So putting a 2 here would be logical. 4 times 2 is 8 and 1. To make it negative, we should have a minus 8. Okay, so hence, what does it give us? So this means we should have y equals minus a quarter or y equals 2. And of course, y equals 2 can't be a solution because in a typical sine x graph, just for logical purposes, we know the maximum value is 1 and the bottom half is -1. And if we draw the curve, you can see it will never reach it no matter how many hoops we go through. So yeah, that's something to point out. If you get big numbers that's outside of the 1 and -1 range for either sine x or cos x, it means you cannot use them. Okay, so let's get back to the problem at hand here then, yeah? So let me just quickly erase this part. Okay, just bear with me guys. So now let's replace y with sine x again and get back to the question. So what do we have here? So now substituting back in, you've got sine x equals -quarter. Taking the inverse of this, so the sine inverse, you guys should actually get an okay, not really good answer. So remember keeping degrees format, yeah? You should have minus 14 degrees, 14.5 to 1 decimal place. Now let's apply the cos rule because that's pretty much the point of this video. Okay, usually we always check this part to determine how to use it. Notice that we have a negative sign here. This means that we do not put angles in the sine part or the or part. All implies that it's positive. If the equation was, for example, sine x equals a quarter, positive quarter, it means that we would use values from a and s. Because we have negative quarter means we will have to work in the non-sine and all. So this means, let's pop out some angles here. So we've got an angle of minus 14.5. It means that we'll be over here at 14.5 degrees. We'll also be at tan y because we're not going to be at S or A. We're going to work with T and C. Remember I told you this was plus, we work here, negative, we work down here. So now all we do is follow this rule. So here we want to be between 0 and 360. We just have to spin it around. So from here, we go all the way around here. Hold on. From here, we travel all the way here. So this is just simply 180 plus 14.5. So let me just write down here. So one of our solution would be 180 plus 14.5. And then once again, our second solution would be going all the way around and hitting here, which is of course a full turn, about 3/6, about 14.5 back. So that's 360 minus 14.5. And that's it, guys. That's literally all we have to do.